David Smith here with another Flip Classroom math video. A few tips before we start. Remember that you can slow down or speed up the playback if that helps you follow along. You can also pause the video at any point to catch up with your notes or to try the problems before I explain them. Finally, you could turn on the captions and read my words below on the bottom of your screen. Today's topic, completing the square. This is the most advanced topic in our Solving Quadratics chapter, and it takes a little doing. I'm going to explain it to you as clearly as I can. We'll do a bunch of examples, and then it's up to you to work hard practicing these problems so you can master the technique. I know you can, you're just going to have to work at it a little bit. Okay, let's get started. So, I'm using one of my trademark instruction sets with steps and an example. So we're going to walk through all of this. I'm going to explain all of this as we go. But before we do that, I want you to look at this quadratic equation. Now we've just spent a bunch of time factoring these to solve them. So if you look at this, you'll notice there's no way to factor this. Two numbers that multiply to -1 that add to +6, no matter how hard you try, those two numbers don't exist. They're not integers. There are solutions to this, we're just not going to find it by factoring. So that's where this technique comes in. Okay? So let's get started. What we do, our first step is to move the constant c to the other side. So you remember, c is the term that's just a number, that's why it's called a constant. So we're going to move it to the other side by, in this case, adding 1 to both sides of the equation. That's going to give us x squared plus 6x equals 1. Okay, so I accomplished the first step. Now the second step is add b over 2 squared to both sides. And what b over 2 squared is it's the b number divided by 2 and then squaring the result. So b is 6. Divide 6 by 2, I get 3. I square 3 and I get 9. So I'm going to add 9 to both sides of this equation. So I get x squared plus 6x plus 9 equals, I'm going to add 9 to this side. I've got a 1, so I've got a 10. Okay? So all I do in this one step is just add b over 2 squared to both sides of the equation. Okay? Now, I didn't change my equation. As long as I do the same thing to both sides, it's still a valid equation. I did not break it. Okay, next step. Factor the perfect square. Now, the particularly alert people on this video probably recognized that this now is a perfect square. That's x squared, that's 3 squared, and 2 times x times 3 does add up to 6. So that fits the pattern for a perfect square. So I can rewrite this as x plus 3 squared equals 10. Okay? So all I did is I factored this side using the perfect square pattern. Now, if that pattern is new to you, or if you just need to review it, I suggest you do that. Okay, last step is just solve. So we've solved quadratic equations like this already in this chapter. My first step here would be to take the square root of both sides. So if I take the square root of this side, that's just going to get rid of the squared. And I have x plus 3. Now I have to do my plus minus square root of 10. I'm almost there to finish to get x alone, which is what solving means. I'm going to subtract 3 from both sides and get minus 3 plus minus square root of 10. And that's good. We're done. Resist the urge to pump 10 into your calculator and get a decimal. Just leave it as root 10. And that's it. You don't have to do anything more. We have what I call an ugly answer, but it's a perfectly valid answer and it's a good number to boot. Okay, let's do another problem. If you're feeling bold, pause the video right now and see if you can complete the square on this quadratic equation. Okay, let's just check. It never hurts. Could I factor this? Two numbers that multiply to 5 that add to 8. Not integers. Really the only way to get to 5 is by 1 times 5. And there's no way I can combine 1 and 5 to get 8. So I can't factor this. So let's do the complete the square. First step, move the constant, the c term, over to the other side. So that's going to give me x squared plus 8x equals -5, because I subtracted 5 from both sides. Now I add b over 2 squared to both sides. So let's step over here and do b over 2 squared. That's 8 over 2 squared. Remember, my b term is the one in front of the x, not the squared, but just the plain x. So b over 2 squared is that. 8 over 2 is 4, and 4 squared is 16. So I figured out my b over 2 squared. Now I'm going to add it to both sides. X squared plus 8x plus 16 equals, now -5 plus 16 gives me 11. Okay? Now, this is a perfect square. And if you've done this right, you don't have to verify, because this step ensures, the b over 2 squared ensures that this is a perfect square. So it's always going to be x plus half of the b term squared. Now it might be minus if that was minus, but in this case it's plus, so we just have x plus 4 squared equals 11. Okay? Now we're in solving mode. We just want to take the square root of both sides. X plus 4 equals plus minus square root 11. Subtract 4 from both sides. X equals -4 plus minus square root 11. And we're done. Okay, let's do one more problem. X squared plus 4x minus 4. Now let's just do our check. Make sure we need to complete the square. Two numbers that multiply to -4 that add to +4. I don't think you can find them. 2 times 2, or 2 times -2 is -4, but there's no way you can combine those to get to +4. And all the other combinations of all the factors of -4, no two are going to combine to a +4. So we know we can't factor this with integers. That's what leads us to complete the square. So let's do it. First step, get the constant over to the other side. So I'm going to add 4 to both sides. X squared plus 4x equals 4. Okay, that's good. I just added 4 to both sides. Now I need to find my b over 2 squared. So that's 4 over 2 squared, because the 4 is the b term. B over 2 squared. So 4 over 2 is 2. Squared is 4. Wow, that's kind of interesting. I had a 4 over here already. The only difference was this is a -4, this is a +4. So that is a difference, and it means that we had to complete the square. So now I'm going to add that to both sides. Now when I add 4 to the existing 4 that's over here on the right, I'm going to get equals 8. Okay? Now, since I did this right, I know this is a perfect square. This is going to be x plus 2 squared. Bring down my 8. Okay, moving right along. Now I'm going to take the square root of both sides. That gets rid of the parentheses squared. X plus 2 equals plus minus root 8. Almost done. X plus 2 equals, oops, x equals -2 plus minus root 8. Now, am I done? Not quite. You're on the hook to simplify radicals that can be simplified. 8 is 2 times 4. So we can rewrite this as -2 plus minus the square root of 2 times 4. And now we know the 4 is a perfect square. It comes out as a 2. So this is going to wind up being -2 plus minus 2 root 2. And that would be our solution. Now that you've finished the video, take a moment to jot down any questions that you have so you can bring them to our next class and get some help. You can also watch the video again to perfect your understanding. If you enjoyed the video, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.